I think, given the time, let's just dig into it. This is Jeff Morset thinking. Looks like we have quite a few people joining. We've got sort of setting up to be conditions that look like an El Nino. The forecasts are for a medium to maybe stronger. You'll learn more about that, but we thought it was useful. I think Andrea Ray kind of started the conversation to say we should have, maybe let people know about the way this is setting up, and then kind of open up the conversation about having, what are the ecological impacts for this El Nino, and if there's any implications for land managers. So really appreciate Andrea Ray kind of calling this to our attention, and Imtiaz being the lead with the climate impacts group, stepped up and brought along Jeff Lukas and Joe Barsugli and the new postdoc Candida there to kind of give us an update of what's going on with this El Nino, and then hopefully we'll have a little bit of time for question and answers about what it might mean and what we do from here. And then we'll do a little bit of the round robin the last 20 minutes or so of the meeting as we have time for the foundational science areas and the funded PIs. But with that, let me hand it over to Imtiaz, and thank you guys for putting this together.
Thanks, Jeff. Let me know if the voice not good on my end anytime during this webinar. So thanks everyone for joining this webinar on what is this emerging and strengthening El Nino event, and what is potential impact for the North Central U.S. So I'm Imtiaz Rangwala, and I have a whole host of team here who put together this presentation. And I'm giving a lion's share of the presentation, but others will chip in as we progress. And we hope to have a lively discussion in the remaining few minutes after the webinar. So looking forward to that. So a quick outline. We're just going to cover a basic El Nino, so an oscillation 101, about what are the current conditions and what's forecasted. Then get into what are the implications for the North Central U.S., specifically in terms of temperature, precip, and snow. And towards the end, we'll highlight some tools for stakeholders, and then we'll get into the discussion. So why do we care about El Nino, Southern Oscillation phenomenon? Basically, it's a global phenomena, although it happens in the tropical Pacific, but it has tremendous power to affect atmospheric circulation that affects climate in our region. So it affects jet streams, the storm tracks, and adds quite a bit of heat in the system that experiences in different ways. It's really a significant driver of climate variability on those timescales globally and specifically in the U.S. So why should we care? Really, a strong El Nino increases the potential for more enhanced extreme weather across the globe. And although the likelihood and its impact varies quite a bit from place to place, we'll get into that a little more later. So what is an El Nino? So it's basically a coupled ocean atmospheric phenomena in the tropical Pacific. And when an El Nino event happens, what it's doing is it increases the temperature in the eastern tropical Pacific, and connected with that is the atmosphere working, helping it to strengthen, and that entails weakening of the trade winds, the easterly trade winds, and it can weaken it, and in fact, there are times when you have westerly blowing in the other direction that further strengthens the El Nino. So really, atmosphere and the ocean working together to strengthen it, and something that we are witnessing at this moment. Related to the El Nino phenomena is also this center of convection that moves from the western Pacific more to the central Pacific, and this really kind of affects circulation at high latitudes. So really affects where the jet stream moves and where the storm track moves, and again, changing climate in our region, or potential to change that. it lasts from several months to a year, and really an El Nino event globally releases tremendous amount of heat from the ocean into the atmosphere land system, and we expect that 2015 will most likely be the warmest year on record, and because both global warming and El Nino just are double whammy kind of situation. And on the other end, we have the La Nina phenomena, which is part of the ENSO cycle, which is kind of pretty much when the whole pattern reverses. It's really a more extreme version of the neutral condition, where you have much cooler temperatures on the Eastern Pacific and much warmer conditions on the Western Pacific. So what are the current trends in this emerging El Nino? And what you're seeing that that temperature in different parts of the Pacific, and here some of these regions known by these codes, have been increasing steadily since April, and especially in the Central and the Eastern Pacific, there's a steady increase. And the data I'm showing here goes back to mid-July. And so what the NOAA CPC is saying is this is a strengthening El Nino. For our region in particular, it's the Nino 3.4 index here that is more predictable in terms of how much kind of an effect it'll have on the North American region. So how does the current event compare to historic event? So there are multiple indices out there. We have basically a limited record that goes back that informs us of the past El Nino events. Really don't have a better record going further beyond 1950s. And I'm showing here two different indices, and what you can see is in these are highlighted some of the very strong and strong El Nino events. And again, there is all kind of definition what makes it a very strong event. And I'll not get into it right now, but as we look at the current event, we can say that it's moving from a moderate to a strong or a very strong event, again, depending on what index we are looking at. We might get a slightly different answer, but we have crossed this threshold into a strong event, and it can potentially be a very strong event. So what is the forecast? And so we use a series of models, both dynamical and statistical models, to kind of inform us where we might head with respect to the emerging El Nino. And the general consensus is that we expect a continued El Nino through the winter and early spring. And most models suggest a strong event at its peak strength.
Imtiaz, this is Joe. May I also add, this is Joe Barsugli, that most of the models show that it is a waning event by mid-spring. This is also consistent with the historical evolution of large El Ninos. They do tend to rebound and come back closer to normal sometime in the mid to late spring. Sometimes they last as long as into the summer.
So moving ahead, so what are the implications for the north central U.S. if we have a strong or a very strong El Nino event? Typically, during the cold season, what we see is that because of this El Nino phenomena, the polar jet stream moves further northward, and so it allows for the southerly warm air to entrain into the northern tier of the country. So we have warm conditions, at least in the northern tier of the U.S. On the south side, we have more amplified storm tracks, which keeps the southern tier of the country wet and cool. There's also a drier tendency in the Pacific Northwest. So what I've done here is looked at some of the analysis from the Climate Prediction Center, where they've put together temperature and precipitation composites for El Nino, neutral, and La Nina conditions. And so I'm just showing for certain climate divisions in the north central how the temperature and precipitation responded between 1950 and 2014. Just kind of, again, providing a sense of what kind of tendencies we may expect in these metrics. So here, the first one is for a climate division representing western Montana. And what we see is, in general, you have, and Joe just pointed out, it's for January through March, so it's part of the cold season. And it varies slightly which section of the cold season we select. But generally, what we find that for the winter cold season, we'll have warmer and drier conditions in the western part of our domain. And here is western Montana. Another western part of the domain is northwest Wyoming. You kind of see the same trend, warmer and drier. And under El Nino, though, is not as strong as for western Montana. Moving to the eastern side, this is from eastern North Dakota. Generally see, again, we see a warmer conditions, and possibly slightly wetter condition than the neutral cases. Coming down further south into central Nebraska, temperatures maybe slightly warmer and not quite significantly warmer, but we do start to see wetter tendencies. And not go nearby into western Kansas, again, temperature, more wetter conditions. So, if you just kind of generalize these results, what we see is for northwestern part of our domain, it's warmer and drier, especially in the headwaters of Missouri and other, and Green and Platte, possibly. Warmer and dry conditions in the Dakotas, mostly warmer conditions, and in the southeastern part of the domain, it's better. Again, these are tendencies. They may happen. They may not. There's a greater potential for warm conditions in the northern tier, but with precipitation, the signal may be a little more dicey. But this is what we see in the record, and we can expect that tendency to be there. So if you use the same data, we can also extrapolate what the snowpack look like, and this is from the same kind of analysis. We are not entirely sure how the snow is derived in the data set. They use temperature and precip to kind of derive it. But this is what the analysis showing here is what are the snowpack conditions in the cold season under El Nino. You generally see potential for below average snowpack in much of the north central region and snow cover. But primarily in the northern tier, as you can see, not so much in the southern tier. And Joe has done some specific analysis of his own to look into the snow issue, and I'll let him talk about that.
Hi, everybody. This is Joe Barsugli. I've been trying to gather some information on snowpack at a little bit more detailed level than was shown in that previous figure, which came from the NOAA Climate Prediction Center. In this case, I'm actually using a snowpack product that's been simulated using a hydrology model, but it's done from a high-resolution gridded historic precipitation and temperature data set compiled by our own Ben Livna here. What I've done is taken those moderate and strong El Nino years that I showed you earlier, and in this case, I'm looking at the March 1 snow water equivalent on the ground. So this is simulated, but it's probably the best way to get a lot of the elevation dependence of snow, and also to get a large extent of a data set that goes beyond where the SNOWTEL data sites are. So take a look at this for broad patterns. One thing you notice is that the Northwest typically gets hammered. Now, this is the average of all these moderate to strong events, but the Northwest pretty much has very much below snowpack. I've done this in inches. This is the absolute departure. So where you see dark red, it's actually greater than 5 inches of snow water equivalent deficit. The other thing you notice is this sort of progression from the Montana, Idaho, where it starts to get up into the far northern Rockies, the greater Yellowstone and Wind River areas for the most part, and north central Colorado. And that's because there's a diminution in the northwest storm track where the storms come in from the northwest and end up traveling down towards the south, and an enhancement of the storm track that comes up from the southwest that hits California, Arizona, Utah, and the Four Corners. The Colorado is, of course, a flip-flop kind of state where it's more so in the southwest corner of the state and less precipitation, less snowpack. You can also see some slight bits of red over in Minnesota and the plains. This particular visualization doesn't show small amounts of snow. Snow has such a large dynamic range that it's often very hard to capture on one visualization. So that's why we showed both of these slides. Did you also show the PET slide? So this is for a summation of what's happened up until March 1st. So pretty much snow in the fall and the spring. This also does simulate ablation processes, so it's snow accumulation minus loss during that period. This data set does simulate other derived quantities. I'm putting out this there. This is more as a teaser in the sense that we could calculate other quantities if they're of interest to ecologists and work with calculating some derived quantities. This is a reference or potential evapotranspiration based on existing vegetation on a relatively fine grid. And it shows this is the more near term because I figure PET is not such an issue in the middle of the winter. So for August, in El Nino years, and I'd like you to look at the lower left panel here, it shows a broad region where there's statistically significant correlations with below normal potential evapotranspiration across Colorado, Wyoming, over into the upper Midwest. If you look at the actual values here, it's about an inch, if you like, a few centimeters per month for the month of August. Notice that as you move into September, which is the right-hand panel, and the lower panels just show only the statistically significant correlations, you see a weak sense that there's some sort of correlation over Utah and the Four Corners, but September is not so correlated. So I wanted to give you a flavor of what we can also be computing beyond just temperature and precipitation. And this is consistent, as we'll see, also with some of the wet forecasts for the near-term future that we will be showing in the next slide.
So next few slides, I'm going to talk about some current conditions and the outlook from NOAA CPC, the seasonal outlook. And so this one, we threw in a slide for soil moisture conditions, and what you see is, and El Nino may have played quite a bit of role here, but quite a bit of wet conditions in much of the Great Plains, except for some of the regions up in the north, including the headwaters of the Missouri. And as I show you the next two slides with seasonal outlook into spring of next year, we may expect more warm and dry conditions out here. And I've just thrown a question down here: what does it mean for at least one of the risks, which I'm defining as the wildfire risk in that region, if these dry and warmer conditions continue into the transition seasons, especially into the spring of next year. So is really the seasonal outlook from NOAA CPC, the most recent one, and just going from fall into the middle of spring next year, and you can start seeing the transition and the response of temperature as the season progresses. And what we're seeing here is more likely a response from these models that show a strong El Nino emerging into winter and into the fall, late fall and winter. And these outlooks are kind of responding to that. And basically what we start seeing is by late fall, we have above warmer conditions, warmer than normal conditions in the northern tier of the country, and more so in the Pacific Northwest and the headwaters of the Missouri. They kind of persist into the spring. As for precipitation, what we see is a drier condition emerging in the Pacific Northwest and really kind of spreading more eastward into, again, western Montana and northwestern Wyoming. So again, warm and dry conditions are kind of forecasted in these outlook for the northwestern tier of our region. So I'll before we draw the conclusion, I'll just let Jeff Lukas talk about some of the ENSO resources and tools where you can get more information. Jeff, are you there?
Yep, thanks, Imtiaz, and hi, everyone. It's Jeff Lukas with the Western Water Assessment, and just want to highlight a few tools, certainly not a comprehensive list, but some that will be useful, I think, in helping monitor ENSO and get a better bead on the evolution and potential impacts to the U.S. and our region as it continues. So the first one, you may have seen, I think Jeff probably sent out one or more emails about it in the last few months, is a beta version of a climate dashboard to cover our entire sort of north central, I call the Rocky Mountains High Plains region. And Imtiaz, if you can click on that link, hopefully we'll see what happens. See if we load it up. Okay. So scroll down, please, and this is just, it's an array of about 40 different climate and water graphics covering, recent precipitation, snowpack, stream flow. If you go down further, we've got CPC, we've got reservoirs, we've got drought monitoring, the CPC forecast that you just saw, and if you scroll down to the very bottom, Imtiaz, the last row is devoted to ENSO monitoring, and so just kind of quick, broad brush, historical Nino 3-4, the different Nino regions, what they've done over the last year. You saw that graphic already, and then the ENSO prediction plume that you've seen, and then this graphic on the far right is the MEI, the multivariate ENSO index, which is a slightly different flavor, and you can click on any of these graphics to enlarge them. So this updates monthly with the new graph, or weekly to monthly as those are available. Okay, if you can go back, Imtiaz, we'll look at the next one. This is a neat thing that NOAA CPC started doing, I want to say maybe 2 years ago, and that is a blog. If you want to click on that, 2 to 4 posts a month. Great. All right, I may have to send out a correction to that URL. Bummer. But they have 2 to 4 posts a month and very engaging and non-technical explanations of key features of ENSO, and some good attention to what are the teleconnections for the U.S. and the expected climate impacts. Thank you, Imtiaz. There is the current blog post features some analogy with Bruce Lee. So I can't recall exactly what that was, but they're really trying to make this accessible to a whole.
I wanted to start naming ENSO events. They wanted to name this Bruce Lee.
Okay. It punches above its weight, right? Yeah. So if you go back, the next two resources are kind of the official, very comprehensive and technical description from NOAA CPC. We don't have to go to it. I'd just show you the URL here. Focuses on what's going on in the tropical Pacific, not as much on the teleconnections and impacts. And then IRI, which is the International Research Institute for Climate and Society at Columbia, has a nice set of ENSO resources. They collaborate a lot with NOAA CPC. Briefings on the forecast. There's a lot of good background info on ENSO and its impacts and how it's monitored and other information. So that's all I wanted to share for now. Thank you.
Thanks, Jeff. So I'll just conclude with these few conclusions, and we can open it to discussion. So what I've kind of tried to present here is a case for an emerging El Nino, which is almost cross the threshold for a strong El Nino event, but it can prove to be a very strong event going into winter and late fall. What does it mean for us? It really increases the potential for above average temperatures in much of the northern tier of the U.S. That includes our region, and dry tendencies in headwaters of Missouri, Green, North Platte. However, wetter tendencies in eastern Colorado, Nebraska, and Kansas. And this strong event can also mean an increased potential for below average snowpack and snow cover on the ground in the north central region. So with that, I'll just open it for the discussion, and hoping to get more feedbacks from the listeners out there in terms of what other research can we do to inform them about what the El Nino could mean for them, and what specific risk they are concerned about that may get enhanced during El Nino. And also, we would like to get other information, if you have, about specific consequences of El Nino in your region, if you can share it in this on this webinar. Thank you.
Imtiaz, this is Dennis. This is a clarification question. Are we in a warmer phase of the DPO, or we're, I guess, sort of phasing out of one cycle into another? And how will that alter or modify this strong ENSO event, El Nino event, that we're coming into?
The Pacific Decadal Oscillation you're talking about?
Yeah, the Pacific Oscillation. DPO.
You want to tackle that?
The Pacific Decadal Oscillation, or the PDO, is a sort of a lower frequency, more amorphous climate variability pattern that's very, very closely related to ENSO. When there's a huge ENSO like this, it's going to be swamping a lot of that behavior. So if this really turns out, I mean, keep your eye in the next few months as to whether people are talking about this being strong or being in the same league as the two biggies, the 77, 78, and 82, 83. Because once it gets really big, it's going to be swamping the PDO. The PDO is in a bit of an amorphous state as it is right now. It is. They don't know whether it's changing sign. It's sort of a lower frequency monitoring of a pattern. So let me just say that that's what I know off the top of my head. I will put it down as a question. I wanted to say that we do intend to come back perhaps in a month or so, maybe 6 weeks, and do an update with preferably with some information that we've generated based on your feedback now or in email. So this is one of the questions that we will put out there.
But the other point is that we're having this El Nino event with climate change, and you know, when we had the last one, a strong one that was almost 15 to 20 years ago. So we have an additional component of global warming on top of that. So again, I don't know what it means. How does a strong El Nino with climate change freezes extremes?
This is Geneva, and thank you guys for this presentation. I wondered, Imtiaz, if you or Joe or anybody else was planning to come back to talking a little bit about potential fire seasons. And I have a couple thoughts, and one is that the way it's looking right now, well, certainly California could have basically a contiguous multi-year fire season. Looking like Alaska could even have potentially a much longer fire season and potentially a contiguous multi-year, sort of a nonstop fire season. I was looking. I just pulled up one of the pages in Bill Baker's Fire Ecology in Rocky Mountain Landscapes, and he talks about a couple of the other atmospheric patterns, not just the PDO, but a couple others. And then sort of to close up, I guess my question is, you know, from my perspective here in northwest Wyoming, despite having a hot, well, because we had a warm and wet at the right time, 2014, 2015 winter, and now 2015, we're going to have a huge load.
Right. So you're generating a lot of fuels now.
Right.
Yeah.
And then you're just speculating that it will dry out, which is certainly a reasonable thing. Do you want to talk about that?
But the only thing that, yeah, I mean, so when you're looking at soil moisture plot, as I showed, and I kind of talked about the wildfire risk, yeah, it's pretty natural that kind of risk emerge in your mind. I mean, I was talking about it to other people who know more about ENSO, and just wondering if any connection with wildfire. The thing I got was that the wildfires are you know, a very complex phenomena. You know, you need source of lightning. You need, I mean, does the lightning follows rain, and then you don't have as much a risk. But in a dry condition, if you have a lightning source, it may mean something else. But definitely, I think the potential, and as you, when we talked about climate scenarios in the future, we talked about issues of wet years following dry years, and how the wildfire risk is enhanced under climate change because the potential for dry conditions with global warming increases during the warm season. So, yeah, I mean, that's all I have to say. That's definitely a concern there that we should not take lightly. But, Joe, you have anything to add?
Let me also say that wildfire is not really one of our major areas of expertise. So I think what we're, you know, and what we're trying to do is provide some background information. People who do the wildfire seasonal forecasts are taking into account all sorts of factors, including the current soil moisture and a much greater knowledge of fire dynamics. So we might want to try to add a wildfire link and try to chase something down that we think is a really credible one, but you probably also know some of that. As you point out, wildfire in different areas, there's a wonderful paper, I can't remember who wrote it, that details across the West which areas in the West are sensitive to precip for wildfire, which ones are more sensitive to temperature for wildfire. And broadly speaking, if it's sensitive to temperature, then you have a much greater chance of having an El Nino impact in the northern tier. But keep in mind that the headwaters of the Missouri is one of the strongest areas of impact of El Nino, and for a large El Nino, one of the more certain. So as you get down into your area, the greater Yellowstone area where you're sitting, if you actually look at individual years, it is a little bit less certain that it's going to be far below normal in precip. But as you said, you're already primed with a lot of fuel. So that of course would be a concern. So we'll try to bring in some more information to whatever we do next, and perhaps if we find some resources, we could send them out to the group between now and then. The wildfire, I'm hearing very clear as a risk, and we'll have to talk to some of the experts on that.
Joe, I'll send a paper that some colleagues that we just got out in the Journal of Biogeography about the climate space of fire, because I think that could be a neat connection. How you were just talking about it, like where is it more sensitive to temperature versus precip?
Yeah, and I can't remember the paper I read. It was just a couple of years ago. Maybe it was out of the Jeremy Littell group. I'm not sure, but I'm not, Orbit. But I look forward to getting that, and maybe we can figure out and talking to them. I don't want to be, I don't want to be too much of a dilettante in the sense of like, oh, that would be really cool, and then talk to the fire people, and they would say, wait a second. You're going the wrong direction. So I'd love to see that, and maybe we can come up with or at least some resources that might inform that. So, yeah, thank you.
Hey guys, this is Shannon. I have a couple comments, actually three, related to the Wind River project and needs and possible analysis. One is You know, for the drought and climate summary that we've been producing via the High Plains Regional Climate Center that Crystal Stiles has been the lead on, she has a section in there for seasonal forecasts, and it would be good to coordinate with you guys to get maybe some more nuanced characterization of some of the upcoming seasonal forecasts vis-a-vis El Nino. So that's one.
And who is that name again?
Crystal Stiles. So I'll follow up with an email, but she's the one. She works for Martha Shulsky at the High Plains Regional Climate Center. So she's been the main point of contact for putting together those summaries.
Okay.
The second thing is Jeff, Lukas, these upcoming workshops that you're having on stream gauge and snowpack data, and the one particularly that you're having in Lander. I was wondering if you're planning on bringing in some of this ENSO analysis into that workshop, because I think that would be of great interest to the water managers.
Yeah, so there's only so much we can cover, and those snowpack monitoring workshops are really about snow monitoring generally rather than what to do with this particular upcoming season given ENSO tendencies. So I don't know that we really, I mean, I'll think about that. I appreciate the suggestion, but I don't know if we've got a role for that in those workshops.
Yeah, think about it, and maybe at the very least just pointing them to the resources where they can find it on the dashboard, if nothing else would be good, and maybe just a really quick overview of that. So that was the second thing, and then thirdly, Imtiaz and Joe and Candida, I know at least Imtiaz, maybe Joe, are planning to be on the upcoming planning call that we have for the climate science team. I think it would be interesting to think about looking at ENSO patterns, this historical analysis you did of ENSO patterns and drought trends and events in the region. So just something to think about.
Yeah, it would certainly be possible to do a closer-in look at the area that the Wind River, that your project is. I know it's not just the reservation boundaries, but the sort of surrounding ecosystems and watersheds. It would be very much possible to look in closer at that region and do a more thorough analysis. Can't be done region-wide, that's just too much effort, but for something like that, where there's a small number of stations, a few snowtail sites, we could bring in a lot more depth to the analysis in a relatively short amount of time.
Yeah, that'd be great. So just some food for thought. Thanks.
Great, thanks.
So this is Jeff Morse. I'd like to, if I could, kind of piggybacking on what Shannon just said, for the additional project management focus projects, of which Wind River is one, to think about, you know, if those other, a lot of the funded PIs are on the call, or their teams, to think about, you know, this will be recorded. I believe MTS can make the slides available so that when you go into those project meetings, to think about, you know, kind of how, and I know you'll have a full agenda on everything else you'll be talking about, but to think about how this El Nino signal might impact management, and then, you know, maybe plant a seed that you think about. There could be a synthesis paper or some kind of compilation of what this means for, like, ecological systems and land management for them. Because I think, you know, we know a lot more about kind of the climate signal and how it plays out and the forecasts that are happening, but what does that mean for connectivity and land use switching and migratory birds and that type of thing? So maybe collectively we could kind of keep in mind, you know, what how this plays out in the next several months, and then think about some way to inform future El Nino events with respect to land management and agriculture. I know we got in the USDA Hub, Wendy and others on the call and interested in this. So just kind of planting that seed and kind of offering MTS as assistance for the Climate Foundational Sanitary as those different management-focused projects have meetings in the next several months or so.
And I'd like to throw out just a couple of weather and climate phenomena that I'm curious whether people are interested in. I know in the far northern region, frozen ground is an important aspect of the hydrologic cycle. It's kind of hard to get at, but I'm not sure whether, given the warm signal up there in El Nino, which is fairly reliable. We might be able to say something about it. Also, I've read something about cold outbreaks also being affected, not just a warmer tendency, but perhaps fewer cold outbreaks. But I want to chase that down if you're interested. But that affects probably the far northern areas, particularly the Dakotas and eastern Montana. So those are the kind of things we could chase down if you think or have heard, or there's anecdotal evidence that your systems respond to ENSO or to El Nino, that 97, 98, or 82, 83 were particularly significant years in your system. We might be able to chase down some more meaningful meteorology to go with that.
There's also it seemed like a strong precipitation gradient at the Colorado-Wyoming border in the Rockies, and also in the sort of, I guess, the eastern portion of Colorado. What drives that really sharp gradient right there, and how flexible or how volatile is that in moving north-south or east-west?
You're referring to, in particular, the sort of broad brush seasonal forecast maps that we were showing about from the Climate Prediction Center?
Yeah, the precipitation patterns.
Yes, is that what you were showing? Let's go back to several pictures, several slides, Imtiaz. Referring to this particular one?
No, there was well.
Or were you referring to the snowpack slide that I was showing, which showed a lot more of the topographic detail here? This one, for example.
Yeah,
this is very common. This is a much more realistic depiction of how the topography interacts with the storm track, and as the storm track changes in El Nino, it affects different mountains differently. And this is also seasonally different. For the early and midwinter, it looks more like this. For the late winter and for the late spring, as you saw this year, the Front Range is actually quite wet in an El Nino year. So a lot of what we've already seen with wetness was the late spring wet signal. But in the midwinter, the storms just are directed further south. They're not coming in over Washington and Oregon and diving down into Colorado. So even in our more high-resolution climate models, you see these 4 bullseyes of lower precip coming in our simulations now. So it really is the fact that there tend to be fewer storms coming in through that traditional sort of northwest storm track. And that's because the jet stream itself has been relocated due to the effects of El Nino from the tropics. Again, these are tendencies, but the stronger that the El Nino gets in the Pacific, the more likely these tendencies will come true.
Does that answer your question, Dennis?
Yeah, partly, but then you also brought up a question about the April-May precipitation pattern with the monsoon setting up like we had this year. And since you only have this to March 1, have you looked at the sort of April-May or 1st of June moisture patterns?
I do. I have these derived quantities, these plots like this for every single month. We just wanted to show them here. The reason both of us, well, all 3 of us were kind of uncertain about showing beyond March and April is that for large El Ninos, they almost always are no longer an El Nino by the time you get into June and May, and they're pretty weak by May. Therefore, those correlations break down. You don't have the forcing in the tropical Pacific that's moving the jet stream anymore. I can certainly make those available. We're just trying to figure out maybe what the best way to do that in a way that's not just information overload. I can certainly share them with you, with anybody who asks me, but
okay.
So yeah, I mean the answer is you tend to get a wetter pattern in April and May, as happened particularly in May this year, but that it's not that likely that El Nino will persist that far into the future. So it's a balancing act by the time you get to the spring. There's much more uncertainty on both counts. I think somebody asked what EC means on these plots, and EC means equal chance of being wet or dry. B is dry and A is wet. So this is a probabilistic depiction, which the probability of being above normal, which is A, below normal, which is B, and where they can't say whether it's going to be normal, above normal, or below normal, they just say equal chances of being in those categories. And the stronger the color, the more the odds are shifted towards being above or below. So El Nino wiggles the jet stream, and where you're between one of the wiggles, one of the large excursions of the jet stream, it doesn't have as much of an effect. So where it tends to create highs and low pressures and troughs and ridges and departures of the jet stream, you do get large effects. But there are regions between those where El Nino doesn't have, and that's why they do this equal chance aspect, because it's an admission of lack of a predictive skill there.
This
Can
is
you hear
Jeff
me?
again. What's that? Yeah.
This is Nikki Altangeli. I'm in Cheyenne. I'm the one that asked about EC. Thank you for answering that. I'm kind of new to this, but we're stock growers, and I've been really happy with the grass this year, but I definitely understand where it can be an issue for fire, and I live out on the prairie, so it's always a frightening experience. But I'm very interested in the precipitation and the temperature for breeding and calving, et cetera. So,
what time of the year are you most interested? What seasons are you most concerned about?
March through April, mostly for having babies. Yeah, March through April. So.
And let me ask you another follow-on question to that. Are you most concerned about, for example, extreme cold event? You know, like if there's a cold outbreak then, or what type of weather is it that really impacts you on a day-to-day time scale at that time of year?
Yeah, blizzards. That's what will kill them. The extreme cold is always difficult because you have frozen ears and tails and everything, but when you have the extreme cold along with 1.5 to 2 foot of snow and the severe winds and everything, that's what is the big issue. That's what kills them. So it's good to be able to see this and be able to kind of follow a model that will give us some outlook, you know, whether it's EC or not. You know, it gives us an option whether to bring stock in close or not. So this has been extremely helpful.
Well, we'll try to follow up on that. And it sounds like you already clearly understand that these are not absolute forecasts, that these are tendencies and probabilities. And we're trying to convey some of the sense of the strength of those probabilities, the shift, you know, whether it's, but as you point out, when you're risking something like a blizzard, you know, I don't have the data to tell you whether there won't be any blizzards then, but it's something that we'll try to look into. The snow question is hard because data on snow is a little bit difficult to process because of missing data and sparse observations, and you'd be surprised how much snow observations there aren't out there. So,
right.
But I'll try to look into something about March and April blizzards. I do know that it also affects wildlife in many respects. I know there have been die-offs of the pronghorn during great blizzards in Wyoming and Montana. So it's something that I really want to do some more research on in the longer term. But we'll try to see what we can get by March and April.
Okay. Well, thank you. I mean, that's our biggest tendency for blizzards. You know, but it makes it a whole lot easier. The weatherman this year has been fairly good. He's actually been pretty much on the money around here. But, you know, it always helps to be able to look at models that are going to give you an idea of what's coming. So.
Right, and again, even if we can tell you that we can't tell you anything, at least it's
exactly.
admitting. You know, I'd rather be realistic about the skill of these, and that's what they're very conservative in their probabilities here at Climate Prediction Center. When they put a number down there, they do know that they really are pretty certain that the probabilities have shifted. But then again, they're not certain certainties.
Okay. Well, thank you very much.
You're welcome.
Nikki, where are you?
We're just north of Cheyenne.
Gotcha.
Great. And I believe Dennis Toddy is online. This is Jeff just asking. I know we've talked a little bit more about the western portion of the domain. I don't know if Dennis is still on and if he's able to communicate any of the kind of implications for the Dakotas, Nebraska, Kansas, anything he's heard of or thought about that might be worth sharing?
Yeah, Jeff, thanks. I'm still here. Can you hear me okay?
Yes.
Yeah, okay.
Yep.
Yeah, you did a pretty good job handling the questions there. From the you mentioned the blizzard standpoint, despite what we know about El Niños, we can't throw out the possibility for one large individual event. We're talking here about season length kinds of issues. So individual, I still caution people, individual large events can still happen in these sorts of things we have to watch out for. From a plain standpoint, there are a lot of the same issues that you will see across the other areas. The last strong El Niños have been very warm for us during the winter time. That's the most consistent signal. Precipitation-wise, it's really hard to get a handle on. There is a fall signal that is a bit inconsistent in the way of precipitation, depending on how you define your El Nino and what you look at. But there is a fall wetness signal that does show in certain composites. So that's something we're going to be addressing at our webinar on Thursday when we talk about that. But the idea of an open winter is very likely. The idea of the impact on the Missouri River is huge. The Missouri River's been bouncing back and forth between wet and dry pretty consistently, and we've seen an example of this year, and very likely could see that again, given what the likelihood of precipitation is for this winter.
Yeah, complete concurrence with you, Dennis, about the chance of a severe event, even if the odds are lower, so that the risk, you have to weigh, of course, the risk of what that event means, and clearly communicate that we're not saying that there isn't a risk, that there is still a risk of those kind of events, at least this far out,
The example I love to use is the hurricane season of 1992. The hurricane season of 1992 overall was pretty benign, except for this one little storm called Andrew. That had a huge impact. So you can have a huge impact from one storm in a relatively quiet overall season.
And Dennis's ranking, we should keep that in mind. The most likely impact is warmth over the further north you go in our region, and also the second most likely is really the dryness in the headwaters of the Missouri River in our region.
Yeah, Jeff, for your comment about the snow data, my perception is that especially the plains are more likely to have a more open winter overall. The snowpack data is a little harder to come by and a little harder to analyze, but given the overall warm conditions, the snow there's not a good signal on, but overall warm conditions, I think it's more likely we have a larger open winter. Okay, and you have something on that since I came on late. Would generally make sense.
Thanks. Yeah, I really kind of want to look more into this because the literature on this is really scattered and often hard to read. And so if we want to talk a little bit more offline about that, because I've downloaded a bunch of data sets. I just didn't have that time to analyze them for this in much more detail than what I showed. So I just think more needs to be said about snow in this region.
This is Jeff again. Another thing I'd like, if you could forward to that slide that shows Joe's the data, the link for the climate dashboard. We have sent email, but I'm afraid these emails might get lost. But I'd ask everyone on the phone, stakeholders, or funded guys, to, if you get a chance, check this out. There's a link that you can provide comments back to Jeff, Lukas on this. They, in the spirit of collaboration, just added to what the Western Water was doing for the previous Wyoming, Utah, and Colorado, and added all the states that are in the north central domain for both the Climate Science Center and USDA Hub. So it was a really kind of excellent leverage, I believe, and appreciate Jeff taking the effort to make this other page, and interested in getting feedback and having people provide comments on that. So just wanted to make sure people saw that as it is a new event, and or a new tool that they could consider.
Feedback link is where?
I think it's just send me, and
up at the very top is the feedback.
It goes to the wwa@colorado.edu address. So
right there, in that second paragraph, or questions, your feedback. There you go.
Yeah.
I think we're close to being on the hour. I want to respect people's time, and again, thank Andrea Ray for calling this issue to our attention. I think at the Open Science Conference, I said we should talk about briefing folks on this. It's been a great webinar. I think it's been very informative. A couple of leads for people to follow up offline on the fire and the snow stuff. And then if people get a chance to check out that dashboard, feedback is welcome. And this is sort of just like an anomalous monthly call. We'll skip any of the round robins, and look forward to getting back with another monthly check-in. Molly Cross is going to review some of the work they're doing with the Wildlife Conservation Society. Actually funds more on-the-ground work than maybe research, and she's interested in sharing that with us, this group, to talk about that kind of shovel-ready type of work, and how maybe some of the science we're doing could complement that, so it could learn from it, inform it, or kind of be connected in some way to that. So that's going to be the next one coming up, I guess, August 29th? No, I'm wrong. August 25th, sorry. And I guess I'll open up any more final comments before we sign off. Okay, well, thank you very much, Imtiaz and Jeff, Lukas, Joe, and Dennis for the input too, and we'll sign off. And this will be recorded and available on the CSC's website. Imagine we'll share the link, and Western Water could post it as well if they're interested.
Thank you.
Thanks, Joe.
All right, thanks a lot, folks.
Bye.